Okay, yeah, this stuff came up. I was looking through the results on the most recent assignment. And this one isn't even due until tomorrow night. But there was some trouble with problems like this. And I think, honestly, I think that this problem, I think maybe depending when you started it, I had to make a little change to it, and it may grade this one wrong. If it does, I'm just going to go through and give everybody full credit on this one. But you got to know how to do it for the test. So let's go through one of these. So if we're told that we want to come up with the equation of a line that passes through a certain point perpendicular to a second line through these other 2 points, what's my strategy going to be? No, that's not your strategy. Any ideas?
Find where they intersect.
Well, not really. We don't need to do that. All we need, now, keep in mind here, and I haven't spent a lot of time reviewing this with you guys because you're experts with lines. But let me remind you of one little fact. If I want to come up with the equation of a line, all I need is a point and a slope, right? And so if I start off with 2 points, I can calculate the slope. In this case, I'm given the point. I just need the slope of the line. Suggestion, right here, yeah.
Find the slope of the line that it intersects with.
Okay, first let's do that. So let's find the slope of this line, and let's call it M2 for the second line, okay? Now that's gonna, how would I do that? What's the ratio I set up? What minus what over what minus what?
5 minus 0 over 15 plus 6.
Okay, I heard a bunch of things, but this would work. So either 0 minus 12 or 12 minus 0, but if I'm gonna subtract these values from these values, I have to be consistent. So 12 minus 0 over 15 minus negative 6, so 15 plus 6. 12, 21 reduces to what? 4 sevenths. So, our slope is what then? Now what's true? Parallel lines have equal slopes, obviously, but perpendicular lines have slopes that are related how? Yes, sir.
Negative reciprocal.
Good. Opposite reciprocals. Very good. So our slope is going to be negative 7/4, right?
Yeah.
So now we got a slope, we got a point, we're in business. From here it's easy, right? All I have to do is then just say, I'll just plug in, I've got values of m, and I have a solution, so there are values of x and y that work. The only unknown I need to solve for in this case is b, right? So if I plug everything in, 15 goes in for y, m is just negative 7/4, and x is 4, so I'll just make that a 4 over 1, how about? Plus b, and those guys cancel, so I just get a negative 7 there. Add 7 to both sides, so b is 22.
Yeah.
So then my line is just negative 7/4 x plus 22. No biggie, right? That's it. Okay, the other thing that I noticed that came up a little bit was graphing inequalities. So let me just give you just a super quick reminder of how we do that. There's 2 steps involved. If we're graphing linear inequalities in 2 variables, there's 2 parts. We got to graph the boundary line, which will always be either dashed or solid, and then we're going to shade one of the 2 half planes that it cuts, that the boundary line cuts out of the xy plane, right? So step 1 is the boundary line. So the boundary line, we'll just ignore the inequality sign, and we'll just rewrite this as 8x minus 4y equals negative 32. But is it going to be dashed or solid this time?
Dash.
They're both. Dashed? Okay, how come dashed?
Because it's not equal to.
Okay, good, because we don't include the line, the boundary line. There's no equal to included with the inequality, so it's going to be a dashed line. Because of that. And then we just have to graph this guy. Now this is easy to do. Later on, I'm going to show you a way to do this on your graphing calculators, but I'm not going to do it yet. There's a great trick. Now, if I'm graphing a line that's not in slope-intercept form, this is what we call standard form, right?
Yeah.
Everybody remember that?
Yeah.
ax plus by equals c. There's a great trick. These are actually easier to graph. They really are. All I need are 2 points. If I want to graph a line, plot a line, I just need 2 points. I plot 2 points and connect and extend. Sound familiar? Right? Okay, plot 2 points and connect and extend. Well, the 2 easiest points to find here would be the intercepts. Now, where is the y-intercept always going to occur? When x has a value of 0. and the x-intercept occurs when y has a value of 0, right? So let's find those two values. Let's go ahead and let x equal 0 and find out what y is. If x is 0, though, what's that first term going to go to? 0. And so this is like the cover-up method. If I want to find the y-intercept, I'll let x equal 0, which means in standard form, I can just cover that term up and solve. Right? Does that make sense? So when x is 0, that term disappears. What's y going to be? 8, right? Makes sense? Negative 32 over negative 4. So y would be 1, 2, 3, 4, 5, 6, 7, 8. Y is going to be right there. If I want to solve for the x-intercept, let y equal 0, which makes that term disappear. Negative 4. 1, 2, 3, 4. And then it's a dashed line, we said, right? So we just go like so. There's our boundary line. Now, which side to shade? All we have to do when we want to figure out which side to shade is test a single point to see if it works or not. If it's part of the solution or if it's not part of the solution. Pick the easiest point that's not on the line, which in this case is what?
0. 1.
How about the origin? 0, 0. The easiest number to substitute ever is 0 into a function, right? As we just saw, a lot of stuff goes away. So if I want to test the point 0, 0, so step 2, test a point, and we'll always test the origin unless it's on the boundary line. Then we'll pick some other easy one. So if I test 0, 0, what's my original inequality going to give me? 0 minus 0 is 0. It's less than, okay, true or false? That's false, right? That's false. So this is not a solution, so we have to shade the other side. Because it's not, if it's, the solutions would represent the shaded part, right?
Yeah.
So the solutions must be over there, so that's our solution. Okay? Make sense?
Yeah.
All right. 209. Let's go.